Hello, everybody. Welcome to today's webinar. My name is Flavio Popescu. I am a sales and support engineer at StruSoft, Denmark. Today, I am joined by my colleague, Ciprian Ziba, who will be taking questions from you. If I can explain a little bit more about that, we will use GoToWebinar for today's presentation. And we would like you to type in your questions in the questions field in the GoToWebinar window. During my presentation, you can type in your questions. We can also maybe take some questions at the end of the presentation if time allows it. Ciprian will be answering your questions during the presentations by typing it to you, by typing the answers in the questions field. So again, please type them in the questions field. Today's webinar will be about pre-stress tips and tricks. Pre-stress is our efficient tool for calculating and designing pre-stressed beams and hollow cores. For those of you who are not familiar with it, this will be an insight of some of the features that makes this program so special. For those of you who've used it, it's a good overview of some tips and tricks that you might not be aware of, or maybe are, but just to get a good refresher. Let's take a look at what we're going to talk about today. We're going to go through some topics. These topics are based on really support questions that me and my colleagues have gotten in time from users around the world who are using pre-stress. And these topics for today are adjusting pre-stressing force. By default, we will have a pre-stressing force, but you can adjust that at any time. Automatic design of stirrups, mathematical results. How does the program actually design the stirrups automatically? We'll take a look at that. Adjusting the strand length. That is a common question and common issue that people come to us and ask us about. Recess beam, which is a relatively new feature in pre-stress. You are able to calculate the recess and design it in a beam with its reinforcement. Creep and shrinkage, how you are able to add creep and shrinkage to study long-term effects and how that affects your calculations. Tension losses, again, something that our users are sometimes in doubt of how this is approached in pre-stress. Importing Hollowcore sections from DWG, and basically good practice rules. You are able to import a Hollowcore cross-section from a DVG file if you have it like that. It's very important that your DVG file is consistent. We'll take a look at that in a second. Topping joint reinforcement. As some of you might know, you are able to add topping to your elements and calculate the reinforcement and stirrups in between the topping and the pre-stressed element. We're going to take a look at that. And the calculation for hollow cores without shear reinforcement, obviously. Okay. Let's start with adjusting the pre-stressing force. As you can see in this slide, the pre-stressing force is one of the columns of the main reinforcement coordinates. And you can actually adjust it at any point. It's not a major issue, but it is sometimes important, especially for people who are starting to use pre-stress. It is important to know that you can adjust the pre-stressing force at any time. Now, I'm just going to go ahead and open pre-stress. I'm just going to start a model from scratch. It's also a good idea for new people to see how the program works. Every time I start a program, I'm required to select a national annex or use the standard Eurocode. I will enter it a name. Length and a section. Let's choose a standard Eurocode section. We'll choose this I section. Maybe I went a little bit too fast through them, but pre-stress has a predefined library of cross sections. As you can see here, you can also define your cross sections. And for Hollowcore sections, you can import them from AutoCAD. I'm just going to choose this for now for my example. I said I can also create fire load combination. If I want to study the fire behavior, this is not on the agenda for today. We have actually other webinars that deal with that. But for this particular issue, I want to take a look at my element here. And I'm just going to put some reinforcement. I can easily do that with adding some layer of reinforcement. Let's put about 6 at the bottom. Whoops. Let's set up the reinforcement here. That's better. And some reinforcement at the top. So it's very easy to add reinforcement and tendons on my element. By default, the bars that I placed at the bottom are pre-stressed. The bars that I placed on top are passive reinforcement. I can take a look at my coordinate system, my coordinate table. And here I can make all of the adjustments for each of my tendons. I can also get a picture here, how the tendons are placed by default. I can adjust these values at any point. So I have my X, Y, Z coordinates. You can see my X, Y, and Z directions with the respective coordinates, the length of the bar, diameter, which all of these I can edit whenever I want. I have the area, which is automatically calculated, and the pre-stressing force here. So I can just enter whatever force I want for the pre-stressing force to be. Then you have the full bond, which in this case is not, it is automatically assigned to at no side by default. But this is useful when you have a slope beam and you want to ensure that the reinforcement at the apex is continuous. So they're working together. So you can ensure that full bond here. But as a topic for a different time. So as I said, you can edit your pre-stressing force here. Okay. Automatic design of stirrups. Pre-stress allows you to set up a layout of your stirrups manually or choose the automatic design of stirrups option. Now, when you make a calculation and you have the automatic design of stirrups active or checked here in the box, the program will suggest a layout of stirrups. But more precisely, it suggests a mathematical value for the area necessary for the stirrups, the necessary stirrup area. So let's also have some examples prepared here. Let's take a look at this one. Here I have a section similar to the one I had before. And I can see that I have some loads as well. I have the self-weight and a live load. And this is a very, very small load, not a big load. The point for this, just make a calculation real quick. This way you also see how you can just run a calculation here in pre-stress calculate analysis, analyze. It's very straightforward. Once you have your element and your loads, you have some load combinations and default settings for the stages, as you can see, from release to final stage in ULS. And you get the results here. You have shear force and deflection. Well, what I'm interested in is the stirrups. Perform a code control after the analysis has been performed. So if I go to my layout now, I can see that the program suggests a layout like this of stirrups. But so this is correct. This is a mathematical result, which is not wrong. But you need to be aware of the minimum requirements for stirrups prescribed in Eurocode. And those requirements need to be fulfilled for your element. So even though pre-stress suggests a layout like this of diameter 8 and a distance of almost 1 meter, you also need to be aware that you need to respect the minimum reinforcement requirements. And this is something that we have gotten a lot of questions about, and it feels that it's a good topic to talk about and make it aware to our users and, of course, new people who are starting to use or will use pre-stress in the future. This is something to be aware of. Of course, I can at any time modify my stirrup layout and redo the calculation. Of course, in this example, the verifications will be okay, but just so you know that you can edit it and customize it and have the layout that you want, even though the program suggests a correct mathematical solution. I think this is it about the stirrup reinforcement. May I also point out that you can set up your reinforcement details here in the reinforcement details tab, diameters that you want to use, the covers for your stirrups, and longitudinal bars, of course. Yes, strand length. Okay, let's take a look at this. Strand length. In pre-stress, as we've seen also in this short presentation, you can set up your strands really easily by using layer of reinforcement. You have also other methods of adding reinforcement. Actually, you have the reinforcement pattern. You can load a pre-saved pattern. See if I can if I actually have one. Yes. You have your default pattern here, and then you just select the bars that you want to be placed. You can create also your own patterns and then save them and use them in future projects. This is just different ways of adding tendons and reinforcement. This is a new feature in pre-stress, the pattern, the reinforcement pattern. But using the layer of reinforcement, I set it up just as I showed you before. And by default, the reinforcement is placed along the whole length of the element. Now, of course, sometimes I want my tendons maybe to start a little bit inward into the beam. That is also very easy to do. I can just set my coordinates here from X, 500, for example. So my element will start from X 500, coordinate 500. That means it will be 500 millimeters inside the beam. It's probably not easy to see it here since I only have one row of reinforcement of tendons, but I do have an example here. They're called when you want some non-adherence. As you can see here, I have several layers of tendons. And if I move this section, I can see how it's very fine points here that describe my tendons, but I can actually see that the more I go inside the beam, the more layers of tendons I have. So it's basically my first 4 start from X0, the next 4 start from 1 meter, and the next 4 from 2 meters. It actually goes all the way to 3 meters. So this is how you can actually simulate a non-adherent tendon, a non-adherent length for your tendons. It is common practice and a very common question as well that we get. It is, of course, possible in pre-stress to model this. It's a simple coordinate adjustment in the X direction. Again, This is a completely customizable table, and all the data and numbers can be edited. Recessed beam design. As I said, this is one of the more recent features in pre-stress. It is possible to create recesses in your beams and make the necessary calculations and verifications for those areas. Let's see what kind of element I have here. I can see I have this type of section already with some reinforcement and some stirrups. Now I'll just make a calculation. My default presentation of all my stages from release to storage and maturing. Of course, I can take a look at each of these individually just by selecting them from the tree. Once I have these results, I can go ahead and perform a code control, which is a verification according to Eurocode. This is a good visualization of the utilization of the element for each of the stages. Now that I have performed a design, I can go to Tools and see that I have a recessed beam option here. Now, as I said, this is a relatively new feature in pre-stress. You can design it both for left and the right. And you have a pictogram here, if you can call it that, with the different dimensions that you need to be aware of and take into account. This is also very, very important that you need to be aware of the position of the supports here and take it and consider it as it is on your element. These positions of the supports are set by default at a certain position. Of course, you have the option to move them around as you please. But this is also taken into account when you consider this. Something to be aware of when you consider these dimensions and these distances. You have your parameters here where you enter them, the different dimensions. So you place and you create your recess as you want. So you can also set the parameters for the verifications. Then you have the reinforcement, and you can see which reinforcement is considered by hovering above these parameters. Those reinforcements are highlighted, so it's easy to follow. And then you have your results here, the load that is considered, and the verifications for the bearing plate, shear capacity, compressive struts, and reinforcement. So you have a whole calculation, a separate calculation here for the recessed beam. This is added to your documentation so you can export it as a final report. So it's very easy to set up the recessed beam. Again, just maybe we're midway. I would like to just re-inform you that you should, if during my presentation, I have my colleague Ciprian, which can handle your questions if you type them in the questions log in the GoToWebinar window. I'm gonna keep moving so we don't fall behind. Creep and shrinkage. This is also an important topic which pre-stress covers, creep and shrinkage, for analyzing long-term effects. You basically have, let's go back to our models. In your load combinations tab, you have the long-term parameters, and you can set up your creep and shrinkage coefficients. These will be taken into account in these load combinations, storage and maturing, and one long-term final stage. Now you can calculate these and enter them here. We also have the creep and shrinkage calculator from StruSoft. That's a web application which you can use for free. I don't have it open now, but let me just open one for you so you have it. Let's see, creep calculator from StruSoft. Use this one. Would have expected to be saved here. But here you have our creep and shrinkage calculator. You basically set up your parameters here, hit calculate, and then you get creep and shrinkage. And you can use these parameters and enter them in your model. Tension losses. This is also a very important topic that we get a lot of questions about. Pre-stress calculates some tension losses. Let's put it like that. Now also you need to be aware that some of the losses you need to consider separately. Now, the losses that pre-stress considers is according to this formula here in chapter 5.10.3 in the Eurocode. Basing this formula that the initial pre-stressing force at a time applied to the concrete immediately after tensioning and anchoring, case of post-tensioning, or after transfer of pre-stressing. So this is the general formula that pre-stress uses. This sigma PM0 is calculated in pre-stress and is taken into account. And as you can see from the slide here, you can find the losses by checking the bending table. Now, it's probably easier and more relevant if I show it to you on a model. Let's see, sure, I'll use this. I'll use this one, okay. Let's go to geometry. Take a look at my, this model's not that nice. Let's look at this one. See if I have any loads here. I do have some loads. Let's see if I can find a better model. One of that. I'm done with this one. Let's use this one. So I can see here that I have an initial pre-stressing force of 1300 megapascal, the one that I set up. Of course, I have different pre-stressing forces actually. But I can just perform the calculation one more time. Okay, And I cannot do that for these models. I probably have too many models open and looking into too many libraries. I'll just close this pre-stress file. Let's close all of these. Okay. Okay. Open a fresh one. Let's see. It doesn't really matter which one I open, just so that it won't just let me perform a calculation. That's what I want to do. It's a simple calculation. Let's see. I have some free stressing forces here. So I see I have 100 and 1100. If I perform the analysis, and the design, I can check table bending. Am I looking at the right answers here? Yes, this is a strange result because I have different pre-stressing forces. So maybe this wasn't actually the best example that I could use. Maybe it was the worst example that I could use. Let's see. Let's look at this one. This is a simple one. Yeah, it just says one layer of strands. So let's perform a calculation for this one. Basically, what you see is the stress after the losses that pre-stress takes into account according to that formula. So if I had 1300, which I think I had in this example, I see that it's a linear increase from the end of the beam towards the interior, and it rests around 1240 for my final. So basically, in this case, my loss would have been 60 megapascal. Let's perform this calculation here too. I can see here I have a linear increase of the sigma s. Let me just make this table a little bit bigger. So I can see here the final stresses after the losses that pre-stress considers, which is sigma PM0, if I'm not mistaken, here. Now all the other losses have to be considered separately. Elastic deformation, short-term relaxation, friction, anchorage slip. What pre-stress considers also is the long-term losses due to creep and shrinkage. So once you have set up your long-term parameters here, creep and shrinkage, these will be taken into account and the losses will be considered in the long-term calculations. So the long-term losses will be taken into account by pre-stress. So this is something to be aware of, and it's really important when wanting to, of course, getting the right calculation, the right values, and knowing which losses are taken into account and which are not, and how to find out these losses. Next up, we have the importing of the Hollowcore sections from AutoCAD drawings. This is a very powerful tool, especially when dealing with complex geometries. And we know that the Hollowcore section have more complex geometries than beams a lot of the times. Of course, in pre-stress, it is possible. I'm just going to open a new one. Hopefully, that won't create too many problems. As I was saying, in pre-stress, you can create your standard sections here. There's a library of different producers which have their different Hollowcores here. You can also create your own, and you can also, so if you choose the option add, you get to create your own from scratch with this different parameters here. So you can see also what types of recesses and dimensions you can add to your section. But probably the best tool to use is import function, which lets you just import a section from the AutoCAD drawing. It scans the drawing and finds the sections that are available. You just give it a name, choose the units, make sure that they correspond to the drawing in AutoCAD, and click import. So you're now ready to use the section directly from the AutoCAD file. Don't need to worry about adding all the exact geometry, which would take a lot of time. They can just use this directly. Now, I think I have that file. Just to give you an example, as a rule, as a good practice tips, it's important that your drawing is as consistent as possible and as simple as possible, really. You want to have as little extra lines and curves in your drawing as possible. Also, make sure that the lines are consistent and no gaps are in between the lines, so you have a continuous contour also for the holes and in the cores. Also, good tip is to have it grouped, all the lines to be grouped in one. This was the file that I imported directly into pre-stress. I'm ready to use it. Let's see where it is. Oh, I haven't added it yet. You can see here my section, ready to add some tendons in the bottom. No. Top ones are good. Maybe these, I need to set up the distance, the cover spacing, so it will be set up properly. But the main point that I wanted to make was you need to have a consistent cross-section, a consistent drawing in the AutoCAD file with no line interruptions. Okay, let's move forward. We have two more tips that I want to show you. Now that we're talking about Hollowcore calculation, this is more like something to be aware of. Is that, of course, you want the shear calculation to be performed without shear reinforcement in a Hollowcore. And this is something that you need to make sure that it is selected in the calculation settings. You need to have shear calculation without shear reinforcement, according to EN 1992. To be sure that you get the right results, please be aware that this option should be that is selected when dealing with Hollowcores. Topping joint reinforcement. Pre-stress. In pre-stress, you are able to add topping to your element. It's very convenient. You can treat that topping. You can add layer of reinforcement separately for that topping, and calculate the interaction between the topping and the pre-stressed element, which implies that you can also calculate the joint reinforcement. And let's see if I have an example here. All of them were closed. No, not this one. Topic chart. In the stirrup reinforcement, I have the option, once I have some topping on the element, I have the option to add stirrups for the topping, which go above the pre-stressed element and into the topping by just selecting the position here of the respective layout of stirrups. And these will be considered as joints. Now I can run the analysis on this one, on this element, which already has some joint reinforcement in it. Let's see how this goes. Yes, and then a design check. In the results, I can check different results. I can choose the bending for the main precast element and the topping, the shear for the precast element and the topping, and I have a table here for topping joint, which is a table result of the relevant values for my topping joint. You can also see here the area of reinforcement, again a mathematical calculation for those stirrups, and the layout presented in my input. So yes, it is possible to create these joints between and study the interaction between the topping and the precast element. These are the elements and topics that we considered were relevant for this type of presentation and this type of webinar. And yeah, thankfully we managed to get them in time. We actually have some time left. Before we jump to any questions, let me just tell you how you can find us online. StruSoft.com is the website. We have here our different products. I want pre-stress. You have all our representatives here for different regions. I should be there somewhere too. Here we am. If you go to Get Started Now, you can apply for a trial license. Just fill out the form and you can receive a license from us. Please contact us if you have questions or would like demos. We really believe that the way to really master this program is by getting you used to it. So once you get a license for testing, you get also our full support and trainings, just so we make sure that you get started with pre-stress. So we're there with you the whole period of testing and trials. And of course, if you decide to purchase the software, you will get technical support from us at any time. I'm just checking the questions myself. I know Ciprian is there, keeping an eye on them. Let me just grab this out here. It looks like all the questions are pretty much answered. Yeah, okay, great. Again, our contacts are here. Drop us an email, give us a call. We would love to talk to you more about pre-stress, either me or Ciprian. Please get in touch with us and start your pre-stress journey now, if you haven't already. All right, that's all from us. Thank you very much for attending and happy calculations.